Now, in honor of Mondays, I just started recording. So quick recap. The segment problems is when we have segments we add together to equal a full segment. And so the first segment is X to Y. The second segment is Y to Z. When I add them together, I get my full length. Now I have two unknowns. I have this blue segment and this red segment. I don't know what they are. I just know that when I combine them, they equal 28. So it could be 20 and 8. It could be 14 and 14. It could be a decimal. So there's no point in guessing because I don't know. What I do know is that if I were to add 3 to X, and if I were to double the X value and add 1 to it, their sum is 28, which again, not helpful at all. But what it has allowed us to do is to create this equation. Now from here, we have a multiple step equation. So the first thing I'm going to do is combine like terms. So I have a 2x and an x. When I combine them, I get 3x. I have a 3 and a 1. When I combine them, they give me 4. So I have 3 x's on the left, I have 4 on the left, and I have 20 on the right. I'm now down to a two-step equation. Subtract 4 and subtract 4. 3x equals 24. Divide by 3 and divide by 3. I get that x equals 8. So now that I know that x is 8, if I asked any other questions like, what is the value of xy and what is the value of yz, I can now use that variable to answer those two questions. Xy is our x value plus 3. Yes. Okay, we have the answer. So what's the answer to xy? And what about yz? And 17. Well done. Because 8 plus 3 is 11, and 2 times 8 is 16, plus 1 is 17. So just using the logic of two things adding together to equal a bigger thing allowed me to create an equation, solve for a variable, and then plug it back in to find the missing values. So before I give you two problems to try on your own, does anybody have any specific or general clarifying questions for this problem? Fine, be that way. All right, so let's try these two problems. I'm going to mute myself and pause the recording. So if you watch this again, you don't have to sit through this time. But please try them at home. I'm going to help people out here if they have any questions, and we'll go over them in a little bit. And if you do have any questions, feel free to just shout out to me or type them into the chat. I will keep looking. All right. So we'll go ahead and start just going over, see if you got the same answers. If you didn't do it, hopefully you understand at least the process of what's going on. So first one, finding x. So I'm just going to take this, combine it. Joking. There we go. Combine it. Shrink it down. Okay. So if I want to solve for what the value of x is, and this was my bad, I probably should have used a different variable because we have point x and variable x, so I apologize for that. But that's okay, I'm over it. All right, so 2x plus 4 is equal to 3x plus 3. Because again, this is the sum of the two parts, and that is equal to the whole of the entire segment. So subtract 2x, subtract 2x. The 2x's cancel out. Here I'm just left with 1x. So 4 equals x plus 3. Subtract 3 from both sides. And I get that x is equal to 1. So now that I know that x is 1, I can go ahead and use that information to solve for my segment and my entire piece. So xy is 2 times 1, so 2. And the entire thing of xz is 3 times 1 plus 3, so 6. So I found my missing variable, I found the piece of xy, and I found the entire length of the segment. What? How'd you get 6? How'd you get 6? There's a little confusion. You did find YZ, which is 4, but it says XZ. So you weren't wrong. I just had to notice that you wrote down the wrong thing. All right, any questions on number 1? All right, then with number 2. Shrink this one down now. All right, so number 2, these two segments add to equal 22. So that means that x plus 1 plus 2x minus 3 is equal to 22. So when I add these together, that gives me 3x. When I combine these, it gives me negative 2, and it equals 22. Add 2 to both sides, 3x equals 24. Divide by 3, x equals 8. So find x, it's 8. xy is going to be 8 plus 1, so 9. yz is going to be 2 times 8 minus 3, so 16 minus 3 is 13. And you can always double check because again, this xy and this yz should add to equal 22, and 9 plus 13 is 22. So that is a little review of something we had done before break with our segment addition stuff. Any questions before we move on to the notes for the distance formula? All right, so we talked about distance formula, where it came from. We talked about Pythagoras before break. This is just going to be what is the distance formula, how to use it, what our answers should look like, and then how we can apply it in a real world situation. Sorry, we just have what we call a jabroni here in school. All right. So first thing you want to have written down is what is the distance formula. So to find the distance between 2 points, you want to use this formula. And now I'm going to go through and just kind of explain what all these symbols and notations mean. So if we want to find the distance between two objects, then we can always have a point of origin or a point of reference and give the two locations a coordinate. It would probably be an X and a Y if that's what we're talking about. But that's the great thing about maps and finding locations is that no matter where you are, as long as you have a starting point, we can just call that our origin. And then how many feet away are you from this? How many feet up are you? And then that's a coordinate point. So we can kind of dictate that based off of the images that we're working on. So when I am finding the distance between 2 points, I'm assuming that I have coordinate 1 and coordinate 2. So x sub 1 is the x value of a coordinate point, and y sub 1 is the y value of a coordinate point. And together, they make x sub 1, y sub 1. So the coordinate point of x sub 1, comma, y sub 1. So they are always with each other because they're both the same point. And then I gave you the x sub 2, y sub 2. So the x sub 2 is going to be the same definition. It's the x value of a coordinate point. And y sub 2 is going to be the y value of a coordinate point. And together, they would form x sub 2, y sub 2. Now I'm just saying that one of the values is the first one and the other value is the second. It really doesn't matter. If I want to find the distance from one wall of the classroom to the other, it's the same distance from that wall to that wall. So it doesn't really matter which order we go in, we're just finding the distance. And that's another unique thing about distance is that distance is always positive. You can go in the wrong direction, but we're never going to get a negative distance because you can't measure a negative amount. So everything that we're working with is always going to be positive. Another thing that's going to prevent anything from being negative is that when we square the differences of our x values and we square the differences of the y's, it's impossible to multiply two numbers that are exactly the same together and get a negative outcome. It's impossible. Positive times a positive is a positive, and a negative times a negative is a positive. So you should never have a negative outcome. So how to use it? Let's say I have 2 points, point A and point B, and I want to know how far away they are from each other. Now, the problems that we're going to start off with are always going to be on a coordinate grid. But if we didn't know the coordinate grid, we would just pick a point to be our origin and then figure out the distance from there. Now, this problem that I set up, I wanted to make sure that it worked out nicely. So I have point A located at 1, 4, and point B is located at 5, 1. And I want to know what is the distance between point A and point B. So I'm going to make point A be my first coordinate point, and I'll make point B be my second coordinate point. Now I'll do this problem out two ways, and what I'm going to do is I'm going to reverse the x sub 1 and the y sub 1 to being the other points so that you can see what that math would look like and on how it's similar and how it's a little different. But first, to do it this way. So I'm going to take this information and I'm going to plug it in to my distance formula. Which again has been derived from the Pythagorean theorem. I know my x sub 2 is 5, my x sub 1 was 1, my y sub 2 was 1, my y sub 1 was 4. So I get 5 take away 1 squared plus 1 take away 4 squared. Or 4 squared plus negative 3 squared. And I did say you're not going to have any negatives because at this point, when I square those two values in my radicand, I get 16 plus 9. Which is the square root of 25. And when we can simplify, meaning when you see a perfect square, please do so. Now in chapter 0, we worked on simplifying radicals. I had no idea what your background was like, how people would be receptive to it, if it would go well, if it wouldn't. Some people did really well with it. Some people really struggled with it. It's not something that I want to fight with people over. If you understand it, then great. You're better off for future situations where you want to reduce and you want to simplify. If you didn't quite understand the concepts, or maybe you've forgotten it, don't worry about it. From here on out, whenever we have the square roots and we want to find an actual measurement, I'm fine with you giving me the decimal equivalent and rounding to the first decimal place, so to the 10th value. In this case, the square root of 25 is exactly 5. The next example I'm going to give you, we're not going to get a perfect square. So I'm fine with you either leaving your answer as is or plugging into a calculator and giving me that value. And so the distance between point A and point B is a total of 5 units. So this is the final answer that we're looking for. And now just to show you, if we were to reverse our x sub 1 and y sub 1, so I'm going to make the 1 be y sub 1 and the 4 be y sub 2. What would happen is we would have 1 minus 5 squared plus 4 minus 1 squared, which is negative 4 squared plus 3 squared. And you'll notice that the math looks very similar to what we had done. It's just that the negative is with the other value. But then once we square it, our second to last step is going to be the same, the square root of 16 plus 9. So you'll see that if you were to switch your x sub 1s and your y sub 1s, it won't matter as long as you switch both x's and y's. So if you make this one x sub 1, that has to be y sub 1. So as long as you don't mix those up, then you're good. But it doesn't matter which is the first and which is the second. So if I want to find the distance between points C and D, and I'm claiming that C is negative 4, negative 6, and D is located at 5, negative 1, I now no longer have a picture. I've just given you the values. Now, like I said, it doesn't matter which is your first and which is your second coordinate point, but I think it's important to label it before we start plugging in the values. So this is my first coordinate point, so I'm going to make this x sub 1, y sub 1. And then by default, this would have to be x sub 2, y sub 2. You may choose to do it the other way. Maybe make the 5, negative 1, x sub 1, y sub 1, and the negative 4, negative 6, x sub 2, y sub 2. It doesn't matter. Just as long as it's x sub 1, y sub 1 being together, and x sub 2 and y sub 2 are together. Now, if I want to find the distance, I'm just going to plug those numbers into my distance formula. If you wanted to kind of visualize what this means, is that if we had an origin and point C is at negative 4, negative 6, that means it's down in the third quadrant. 5, negative 1 is in our fourth quadrant. So wherever our point of origin is, both of these points, one is down and to the right, the other one is to the left and a little bit down, and we want to know what is the difference between those 2 points, what is the distance between those 2 points. So the distance is equal to x sub 2 minus x sub 1, be careful of those double negatives, squared, plus y sub 2 minus y sub 1, be careful of those double negatives, squared, and the square root of that. Again, I have encouraged you, you can use a calculator whenever you want, but I'm going to simplify this out just so you can see the steps. So 5 minus a negative 4, when you have those double negatives, then it changes to an addition problem. If you take away something that's negative, then that would be a positive thing. And again, I simplify. 5 plus 4 is 9. Negative 1 plus 6 is the same thing as 6 take away 1. So I'm getting 5 squared. And so I am getting the square root of 81 plus 25, which is the square root of 106. That is not a perfect square, but I can just leave that as my answer. Or if you'd like to, you can plug it into a calculator and get a decimal equivalent. Now, do I know exactly what the square root of 106 is? No. But I do know that the square root of 100 is 10, and 106 is a little bit bigger than 100. So I would say that this is 10 point something. What that something is, I don't know. I grabbed this problem out of the book. They said the answer was about 10.3. But the square root of 106 is also fine by me. So we had an example where it worked out nicely. And then this one, not so much because of those double negatives. We still had some extra negatives. But then once we squared it, it came out pretty nice. Any questions with using the distance formula? So I'm going to give you 2 problems now for you to try. See if people in person have any questions. And then obviously answer your questions if they come up. Okay. All right, so try these two problems. You'll find the distance between M and N and the difference between J and K. And in a moment, we can go over the problems. I'll go ahead and mute myself and pause the recording. All right, so let's go over these problems. Again, the first thing I'm going to do is just identify what's going to be my first and second point, just so that I know what is my x sub 1, y sub 1, x sub 2, y sub 2. Nope, that's exactly what you don't want to do. Good lesson for you guys. So again, x sub 1, y sub 1, 2, y sub 2, and I'm just going to plug it into my formula. So I'm going to do negative 3 minus 2 squared plus 2 minus 4 squared. And now if I have negative 3 and I subtract 2, I know that some people like to rewrite. Oh, that's good. Just switch back to my. Rewrite it so it looks like that, because negative 3 minus 2 is the same thing as negative 3 plus a negative 2. And that equals negative 5 squared plus negative 2 squared. And so I'm getting the square root of 25 plus 4. So the square root of 29, which is somewhere between 5 and 6, because the square root of 25 is 5, the square root of 36 is 6. That's a little bit closer to 25 than it is to 36, so I would say that this is going to be about 5.3 or about 5.4 if I had to guess. And then again, x sub 1, y sub 1, x sub 2, y sub 2, and plug it in. So negative 3 minus 4 squared plus negative 7 minus 3 squared. So I get negative 7 squared plus negative 10 squared. All these could be different based on how you plugged in your numbers, but what we should all have is the square root of 49 plus 100, and I'm getting the square root of 149, which I know 149 is between the perfect squares of 144 and 169, so between 12 and 13. Definitely closer to 12 than to 13, so I'd say this is about 12.1, 12.2, somewhere around there. So if you went ahead and plugged that into your calculator to get your decimal equivalent, that's what you should be having. Again, around 12.1, 12.2, and around, I would say, about 5.3. Any questions with the distance formula? All right, we're going to end today with one word problem. And that word problem is going to be centered around game of football. And the field obviously extends, but we only care about this half anyway, so it's fine. All right, so in the game of football, you have your quarterback. That is the one that throws the football to tight ends, receivers, running backs, or any other eligible receiver. Now, as a quarterback, you have to be able to judge where your runners are running to, how far away they are, and so you know how you're going to throw the football to them. Are you going to be throwing it into a line drive because they are close enough that you can just throw as hard as you can? If they're too far away, gravity is going to pull down on that ball, and it's going to then start to go a little bit closer to the ground, and it might be too hard of a catch. If they're further away to get more distance, you want to throw it up a little bit higher so you can get more of an arc. And so as a quarterback, you know how far you can throw a football. You know what type of throw you need to do and when. But what you need to know is how far away your receiver is so that you know, do I have enough strength to throw it right into his chest, or do I have to arc it a little bit to get over the defense and just place it in that correct spot? So what we have is that we have one player. We'll call him Luke. And this pen keeps changing on me. So we have Luke. He's located right here, and he's heading towards the sideline, but obviously he doesn't want to get out of bounds and give his quarterback a little bit of space. So he is on the 20-yard line, and we'll say that he is about 5 yards off of the sideline. That's not too clear. Let's try that again. 5 yards from the sideline. Now the quarterback is over here in the middle of the field. We'll call him John. So John is in the pocket. He's in the middle of the field. He's got his line around him, and he's looking for Luke to throw, and he wants to hit him straight to the sideline. It's a close game. He needs to get out of bounds, but he wants to get it to him as quickly as possible. So what John is thinking in the heat of this game is how far away would Luke be from him? And can he throw the football that far? Now, this is an instance where we do not have any coordinate points. We just have two people in existence on a football field. But what we can do is that we can create our origin, and then based off of that, we can assign both Luke and John a coordinate point where we then plug into our distance formula. So right here is a pretty important spot on the football field. That is where Luke would then score a touchdown. If he crosses the field, if he crosses that plane, then he will score a touchdown. So I'm going to make this little connection between the field and the end zone being 0, 0. Now from here, I can assign coordinate points to each player. Now we have Luke. He is 20 yards away from the end zone and 5 yards up. So my X value will be 20 and my Y value will be 5. So Luke's coordinate point is at 20, 5. Now John, we're going to say, is about, let's maybe 20 yards. Yep. Just make sure, yeah. I'd already done this out. I want to make sure it matches the answer key. So we'll say that he is about 20 yards up the field. So football field is a little over 53 yards wide. So he's almost in the middle, a little bit closer, but that's all right. And now how far away is he from the origin? Now this might be a little deceptive because you might write 40. However, starting from here, 10, 20, 30, 40 is over here. 50, he is actually 60 yards out from the end zone. So that means that John is at 60, and he's 20 yards away from the sideline. So I want to figure out how far does John have to throw this football to get it to Luke, rounded to the nearest 10th of a yard, we'll say. Yes?
Are you trying to do this more for math or for realistic standpoint? Right? Realistic standpoint, when you're starting at the end zone line, probably starting a little bit ahead of that.
So the question is just about the diagram. The only reason why I started from here is just so I know how far away Luke is from, so that I could give him a coordinate point. But you're right, if this was more of a real world, we'd also have to take into motion the fact that both are in motion and then the rate at which they're changing as well. But now you're talking about calculus and where that all comes in. Yeah, right? Yeah, racing and calculus, football and calculus, baseball and calculus. Calculus just makes everything better. All right, so my X sub 1, Y sub 1, I'm going to say is 25. And my X sub 2, Y sub 2 is going to be 60, 20. So due to our time constraints, I'm going to go through and do the problem you may have already started. But I'm going to subtract my X values. So 60 minus 20 squared plus, and now I'm going to subtract my Y values. So 20 minus 5 squared. Now you'll see what I decided is that I did keep the bigger values as my x sub 2, y sub 2. So when I subtract, they weren't going to be negatives. And so I get 40 squared plus 15 squared. And then from there, you want to plug it into your calculator, or you can start to do some mental math as well. So I'm getting the square root of 1,825. Now that doesn't really help me much when I'm talking about measurements. So how many yards would that be? So I'm going to go ahead and take the square root, and it's about 43 yards. So we'll say 42.7 yards. So John obviously knows how far he can throw a football before having to arc it more. If the defender is right on Luke, that means you really got to zip it in there. And if he can only throw 30, 35 yards with a straight line, then that's going to be too hard of a pass to throw to Luke. He's going to have to arc it, which means he's going to have to lead him closer to the sidelines, things like that. So you can start to make adjustments. Obviously, John isn't taking out a pen and paper when he's on the field and figuring it out, but it's just kind of the analysis of it, and that's where math comes in. So anyway, so let's go ahead and stop this recording.